grins widely. Good afternoon. Good afternoon, everybody. Hope your day's going well. My day's going fine. Got my dynamics midterm back. Oh, it went fine. I was like... Was I above the average? Yeah, I was above the average. I was below the median, but... Like, right around the median. Not that below the median. But I'm here. I don't... I didn't know what I got points off on, so I might have just, like... She might have just taken, like, 3 points off for me not writing vector hats on every single vector I wrote, which, I tend to not write vector hats because I write a lot of vectors, but I don't write, like, scalar plus cross vector, so... I don't know. We'll have to see. That's not what we're here for. We're here for FMA stuff. That's exciting. It's fun. Let me pull up... Oh god, I have to recite into this. It's fine. I'm normal. I'm gonna pull up a new one. Because I feel like every time I start a new one, I always get a little bit better. And I get a little more frustrated with one that I've been working on for a while. Let's start with a new one. Although this one was going fine. I think one thing that I might... Because I got some crazy off answers, and I was like, what is happening? And I think it might be actually because I did not convert to feet. And everything is in slugs, so that might be part of it. Oh god damn it, this is the... Wait, I messed up... Did I mess up 6.21? Let's see. Maybe we can do that one, because that one seems kinder to me. Oh yeah. Oh, I just gave up. Okay, well I didn't give up. I got this one right, and that's great. We love getting things right. Oh, I see. I went back. We could... Oh, like this one. This one. This is like... It's supposed to be like 9. Let me... If I divide this by 12, what do I get? And let me see if that matters. I was like, oh, all the units are in inches. I don't have to change anything because they're all in inches. But let me see. By 12. No, that's still 53. Okay, there's some other issue in here. So maybe we'll start with this one because this one is actually like a pretty... Oh wait, that's not the one I was thinking about actually. Wait, we can do this one. Oh, this is great. This is great. This is one I haven't tried yet. Okay, I'm just gonna delete everything actually. All right. We got a lovely eccentric wheel or semi-cylinder. There's stuff all over my desk. Sorry, I dropped my pad. Okay. I drew on it. I don't like that I drew on it, but that's fine. Alright, so we have a weight W and a radius R is released from rest. Great. Our omega O equals 0. Determine the minimum value of mu s for which the hemisphere starts to roll without sliding. So we want to say that like mu or ff equals mu sn. That's the situation we're looking at for the first one, and the corresponding acceleration of point B. Great, so OG equals that R, and by parallel axis theorem, okay. That's some extra information about I-bar, but we don't need to do that right now. We're gonna start with free body diagrams. Kinda wanna make this beautiful. Let's do that. It feels like beautiful in a way. Oh, you didn't see that, okay. I just want to make it like sort of romantic, you know? I don't know why. To me, drawing like a full circle and cutting it in half is more... It's alluring. It just looks better. Maybe it's because I can draw a better circle than I can a semicircle, I don't know. Okay, well let's put some stuff in here. So O's here. We got G. And our weight acts on the centroid. So I guess it gives us a weight, so we can do weight. We're gonna have to turn to mg at some point, but for now weight is fine. Yeah, we're chilling. Okay, then we've got a normal force, and that's gonna act here. Because that's the point where it's touching. Which is sort of unfortunate. Gonna have to take some moments. Let's see, what else do we have? We have a friction. But we don't really know what way that is yet, so maybe we'll just put in a sort of dotted line. There. Friction will be one way or another. And then we have some accelerations. So we know that there's going to be an acceleration. I guess we'll put it up. MAY and MAX. And we should put in some axes. I kind of like to put in the axes like really big across the whole thing so that they can't get mad at me for not having them on both diagrams. Kind of feels like it pushes them like together in the space more too. Not that it really matters, but all right, and then we have a rotation too. So let's just, for the sake of things, it's not going to rotate upward, but let's just say it does, just because then I don't have to put in negatives. I don't do that for statics, but I do that for dynamics. So we have to deal with that friction. So let's see. If we take a moment about... the weight, and we say, well, okay, we know it rotates down, so that's not really going to help us that much. And if we take a moment about n, our FF would go away too, so we can't really say exactly what the direction is, but maybe we can just guess. I mean, let's say it's positive, and we'll see if that screws us up. We do know the magnitude of it, so that's gonna be good, but we don't know the direction. All right, so now we need some equations. What's a good one? Looks like sum of forces in X is going to be nice, because we know some stuff about FF. So that would give us FF equals MAX equals mu sub Sn. So we know AX in terms of n, which is nice. What else? We can do... I'm a little hesitant to do forces in Y right away because, I mean, we'll get the normal force in terms of the Y acceleration, but we don't really know that much about the Y acceleration. Maybe we can start with a relationship though. Let's say this. So we know that, well, we know the acceleration at O. And we need to know the acceleration at G. So we can say that. That's a good one. We know that it's O plus the acceleration of G with respect to O. And we do know that AO is going to equal alpha R. Because that's the center of a circle that's rotating. Even though, I mean, it's not a circle, but it's a circular motion. Because it's not going to have any omega, right? So if at this point, if it had an omega, then, you know, we'd have to factor that in, but I think it would still cancel out. I'll be real, because C would have one and then we cancel out with A, but whatever. Omega R, and then I guess in this case that would be, we can write that as a vector. So that'd be like negative alpha R. Did I say omega? It's alpha. Negative alpha R. Like that. That's pretty good. That gives us some stuff to work with. For sure. What else have we got? Well, we can start chucking some stuff in here. Oh, well, we should probably do AG with respect to O. That's a good one. This is going to equal negative alpha R. I know I defined it down there. Don't look at that. And then we'll have plus. I'm going to do... I like to just write the cross product because I don't know, it feels like nice to have this sort of guiding equation, and I can just put the radius in and I don't have to like, I can just visually see it, but you can just do a cross product. Doesn't really matter. Okay, so AG with respect to O. So G with respect to O, that's going to the right. And that's going to be 3/8 R. So we have 3/8 R, 0, 0. And then we'd have minus omega squared, right? But our omega is 0. Because we know that from the start over there. So that's good. I'm actually going to pop this one up so I can have this line. There we go. All right, so if we do this, it's going to be negative alpha r 0, 0 minus alpha 0, negative 3/8 r 0. Clean. Nice. All right, and that's going to equal AG. So that means that we have some components, which is great. I love that. So we know that like MAX is equal to this, and or MAX is equal to this, right? And MAY is equal to, well, not 3/8. Let me finish writing it. 3/8 alpha r times alpha r. That's probably a lot better. Let's kind of check our understanding. This is saying that it's going to go sort of to the left and up, which if it was rotating upwards, it would do that. Now, it's not going to do that, but it would go to the right and down if it was wait, it would go to the right. Would it go to the right and down? That seems a little weird. Oh, hey, it's Silly. Hi, Silly. How's it going? I need more things here. I don't have enough things. I probably need to take a moment. I don't really want to do that. I don't want to have friction in there. I'm a little worried about the friction. But we need a moment because I need some alphas in my hand here. Let me just try it just for funsies. What if we did a moment about G equals I bar alpha? That's fun. It's going awesome. I finally caught one of your streams again, so I'm chilling. Aw. I'm glad to see you around. I always like it when I see a friendly face who hasn't been around in a long time. It's like a family reunion. How about you? How's it going? It's going well. I'm doing well. I'm a lot less sick. I say less sick because I still have like a little cough, but yeah, we're going through it. That sounds like I'm having a bad time. I'm having an okay time. I say that only because I have to do dynamics. But it's a living. Oh wait, actually no, wait, we're so back. Wait, what am I trying to find? N? Wait, okay. This is maybe okay. Sick buddies. Oh, did you get sick too? I'm a lot less sick because I stopped streaming when I was sick. I was like, cannot do that. Ooh, oh god, I mean, I guess they just give me iBar up there. I don't really want to. I had the flu for like a week now. Metal pie. That's the sickness. You know, maybe I don't know what I had. I only tested for COVID and it wasn't COVID. It could have been the flu. I don't know. Everybody was getting sick. I was also working a lot, and I'm gonna do FY real quick. Oh my god. Oh, it's Drown Him Friday. Oh, I'm drowning. Wait a second. I will take a sippy. Oh, I actually have water. Let me. Well, the flu's been going around. Yeah, it's also just like the plague, you know, being on a university campus. Oh, I miss getting drowned on Fridays. Where would I be without drowning him Friday? Okay, and mine is way equals FMA. Okay, I got like a bunch of shit and I don't know what to do with it. That's kind of how these problems tend to go. Surprised I don't have the flu given for my entire weekend-long robotics comp, and our coach had flu and strep. Oh, I forgot strep was a thing. Maybe that... I don't know. There's someone I know who has like a throat thing going on. I just like forgot strep was a thing. Maybe he has strep. That sucks. That's awful. The flu and strep at the same time. I feel like everyone's getting sick so bad. But then again, I was thinking low-key, like, I mean, like, RSV is kind of a thing around here, too. Okay, I need mu sub n. So that needs to get put into here. Okay, how many unknowns do I have? Let's see. 1, 2, 3. I have 3, because these are expressed in terms of this. So I really only need 3 equations somewhere. But where? Well, which ones? That's the age-old question. I guess maybe I should start by translating them into... Oh, wait. If I just do this, u sub Sn equals negative m alpha r. Then we have negative n times 3/8 r plus r times mu sub Sn equals I bar 2/5 mr squared. 2/5 mr squared minus, I don't know, m times, God, 3/8 r. Look at this. This is awful. Okay, my glorious king, my friends are dragging me away to play Jackbox. Bye bye. Have a fun Jackbox. Jackbox is great. I hope you enjoy. This, like, is a lot. This is a lot. Oh, you can't even see it. Damie, when will you join me once more? What? When can we frolic and play? Frolic and play Jackbox? Anytime. Well, okay, anytime is a stretch. Just like, let me know. M times 3/8 alpha r. I love a good... I was gonna say something and then I was like, oh, I shouldn't say that. I love a good box. I love a good playing box. Evil mode? Oh, it's not gonna go because I'm drowned. It's gonna, well, it'll go later after I'm done drowning. Man, why are there so many unknowns right now? This is like a lot of unknowns. Why can't I be evil and drowning? I don't know, ask my, mix it up. Oh, good. God. Okay. I can substitute, what if I just solved for, this is so fucked up. Grr, grr. Yeah, this is how I feel. I have too many, I have all these guys, but what do I do with them? How do I get them to go together? Can I blow up? You mean my mic? It'll happen. Don't worry. It's gonna happen. How do I just like do this in a fresh, fun way? I can't like get rid of everything. What if I just turn everything into alphas? Okay, maybe I can do that. If I turn n, okay, so n equals... Turn all my unknowns into only alphas. That's like some like Omegaverse plotline. The answer is 13. I went to go look at it, it's not there. I don't know, maybe it is. That'd be really unlucky if it was 13. Because 13's unlucky. But I would also be so impressed if it was 13. How do I actually do this? Like, it's here. Like, I've set it up properly, but now I just can't algebra. Oh, I'm evil now. Grr. I know exactly what to do. Oh, I dropped my pen. Yay. La 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 la. What's happening? I can't even cross out any M's. Can I like solve for alpha really easily, maybe, please? What if I did that? What if I solved for alpha? Okay, what about this? N equals M G plus 3/8 alpha R. Let me say mu sub s times G plus 3/8 alpha R equals negative alpha R. I cancel out the M's. Solve for alpha? True. That's what we're doing. Okay, so this is like me. This is me messing around in my evil potion concoction. Okay, so I got this, which is kind of close, but I need alpha, which is what? There's gotta be a better way to do this. Like, this is so simple. I feel like the key is in this one. I'm so sure that being a math head sucks. If I had to hear alpha sigma every day, I would. You know, in Ratatouille, where it becomes a kid again, but it's me reading Tumblr posts at 13. No, it actually is truly like that, but it's really funny. I feel like it's a great experience because it's like you hear it so much that like you don't really think about it, but sometimes it just like hits you like a truck. Like, my electrical engineering teacher said the words One Piece in lecture, and I just shot up. I just woke up instantly. I was like, One Piece? Sleeper agent. It's real. The One Piece is real. And then I started crying like this in class. Can we get much higher? Sad damie noises. I don't even know what that frame is from. I think it's from a movie. I don't think it's in the manga. Me when I was like majoring in pathologic, the hit video game go eep. Oh, that's so true. Okay, psychic brainwaves. I need my evil. I feel like, okay, what type of magic disciple do you think dynamics is? I feel like it's a warlock subject. I don't really think it's a witch or like a wizard subject. I think it's a warlock. What do we think? Yeah, druids also option. Cleric also option. What else? Sorcerer. I think it's a warlock. It said a little bit, evilly, a little bit meanly. I think it's a warlock subject. What can I get? What can I do with any of this? Am I a little bit evil? I'm turning a little bit evil. Yeah. It's fun. I put the numbers in the washing machine. It's actually really funny though, because it's been 3 years since I've had to like learn how to do physics, and this is like a new experience for me to be so cognizant of like myself and be like, wow, I just like don't know how to put these pieces of this puzzle together. You know the image of the guy that's like he's got like the giant puzzle pieces. He's like, okay, wise guy, you do it. This is how I feel. That's how I feel doing my day. I think it's Joe Biden, right? I'm like, okay, wise guy, let's see you take a crack at it. It's exactly how this feels. I know they're right there. It's like, I know what they're supposed to be. I just can't see the pathway. Ugh. I feel like it has to be through ends. So n equals mu sub s. And you also get n equals the m times g plus 3/4 alpha r. If you set those equal to each other, the m's cancel out, and you get mu sub s equals some stuff. And on this one, oh, I mean, I guess I can also just solve for n here. Not that doesn't really help me. Why is there no... I mean, I could also just put this in like a washing machine. That's my way of saying, did they actually give us a mass? Oh, of course they didn't. You know what? Let's traipse away in the fields, and we'll come back to this one. Because it's set up. It's just not so. Oh, this is another one. This is like supposed to be 6 newtons. Got 99. Wait, what's 99 divided by 12? This isn't even in feet. So I can't say like I divided it by 12 and it was right. Okay. Let me get into the mindset here. I need to carnally get to know this problem again. Okay. Oh god, I love this song. Dude, Super Paper Mario music was so groovy, and for what? It really popped off. Okay, the center of gravity, this actually is total dynamics music. Like, this is dynamics. If you listen, you're just like, that's dynamics right there, baby, engineering dynamics. Okay, center of gravity is located at distance r equals 18 millimeters. Okay, so first off, did I change everything into millimeters? I did. Okay, good. What's geometric center B? The radius of the wheel is 60, and its centroidal radius of gyration. Also, crazy name of a thing to have exist, a radius of gyration. This song was produced using a dynamics. Yeah, they just put dynamics in a computer, and it made this song, actually. I love the concept of a radius of gyration, because it's like, we just kind of gave up, and we just said, what if everything was a big ring of mass instead of anything else? And that's close enough. In the instant shown, it has a velocity of 35 to the left, and acceleration of 1.2 to the left. Knowing that it rolls without sliding, neglecting the mass of the driving yoke AB, determine the horizontal force P applied to the yoke. Okay, so let's check our free body diagrams. So it's going to rotate to the right. Or, no, it's going to rotate to the left. It's going to rotate counterclockwise. And it's going to move to the left. Why did I draw... Oh. Okay, I was wondering why I drew... excuse me, this arrow, but it's the 1.2. I have hiccups. 1.2 is that. And then this one is MAX. So... we know about the acceleration at this point, we'll have to relate it to the acceleration at that point, which I did. Did I? Yeah. The center of that, so we can find that alpha, yeah, okay. Yeah, so VB is going to be omega times R, so if we take VB and we divide it by R, which is 0.06, then we get, let's just check that that's the right number. 0.06? Yeah, 5.3, okay. I mean, that makes sense. Acceleration is 1.2 divided by 0.06. That gives us 20. Okay, great. Beautiful. I have a lot of stuff here. What is happening here also? Why did I write this out like this? I took a moment about C. Because we don't care about the friction, we don't know about the friction. And so we want a moment about C. I agree, that like sounds kind of great. Let's just check to make sure we have all our forces. We have a weight, directed off to the side. We have a normal force, directed, you know, center. We have the P, friction. Yeah, I agree. This is good. We got the accelerations on the centroid, so we don't have to worry about that. All right, if we take a moment about C, we're gonna get. Oh, I see. So we're gonna, I said that we have a moment that's caused by the acceleration at G and a moment that's caused by the acceleration at X. So maybe the distances of those are a little off, and that's why I got it wrong. So P is the 0.06. The radius of the wheel is 60, so that's, we're chilling there. I bar alpha that'll be a value that we'll get from the radius of gyration, which is 44 millimeters. Okay, well that's already the, that's probably why, because I did 440 millimeters. That would make it a lot bigger. Okay, that's one thing. Let me actually draw that in red. 0.044. See that? There you go. Okay, so then we have a moment of m times ax, and that's going to be how much above c? It's going to be the radius, so 0.06. Great. And then we have the 0.18, or 0.018, which is our offset from the MAY, right? So we want this horizontal distance, and that's 0.018, or 18, whoops, 18 millimeters. There we go. Okay, that seems right, and then we just have to, yeah, we divide all that by, so let's see if this is closer right now, that it's the right numbers. Okay, so we got 0.044. And we can also check the signs. Okay, so for MAX, if we curl our fingers in the direction of MAX, that's going to go up, and MAY about C is going to go up, and P is also going to go up, which is great. Or sorry, they're all going to rotate counterclockwise. 0.06 times 1.125, and then 0.018 times 0.6. Add these all up. I actually probably bet it was me not putting in the thing correctly. 3.8. Okay, that sounds a lot more reasonable. Let's see. If that's right, I'm going to be very, very happy. 3.85 newtons. And it still asks us for another thing, but if we don't get that 3.85, we're kind of borked anyway, so. Please be 3.85. Please be 3.85. Okay, it's 8.26. Okay, why would that be wrong? Okay, velocities could be wrong. Let's check those. So we already checked the VB and AB. I kind of squished this in here, apparently. Okay. I got rid of the... Oh. No, we're okay, we're okay. Because I got the omega. As I say, maybe I just didn't put the velocity right, but we just need the omega, so it doesn't really matter. Okay, so we got negative 1.2. Then we have 20, which is going to be our, this is our atangent cross R. And this is G with respect to B, so we're going in the positive direction with we're pointing to G from B. B is our center. So 0.18, that is the distance that it is. And then we have minus our omega, which we got up here. And times that same thing. This is going to be a minus 20 times a minus 18. And then that's minus. So maybe I got the signs wrong. Let's see. So 20 times 0.018. That's a positive. Oh, wait, never mind. Maybe I got the signs wrong on the other one. Let's see, negative 1.2. That's going to be a negative value, so plus 5.883. Sorry, 5.833 squared times 0.018. Nope, I also got that one right. Fascinating. We have the acceleration of g right, and then we just orked it somewhere. Maybe if I take the moment out c, and then the friction force go away, we don't have to worry about the acceleration of whatchamacallit, of point B, because g is the one where our acceleration exists. Did I plug? No, alpha's right. My mass is right. This is weird. Huh. 36. Oh. I see. I see. This is a negative. Would that matter? That might make my answer worse. Because it'll be minus the middle term, and then it'll be smaller. Uh-oh, it's negative. Wait, is that good? I don't know. That might be worse. Yeah, that's worse. Okay. Oh, no, you know why? It's because I don't need a negative because I already did the sign for it in terms of the moment. Yeah. I did it by hand instead of by, I did it by inspection. Never. That is fascinating. I don't know what I'm doing. Unless there's just something like, you can see I started writing the vector signs here and I just gave up. Because like, there's too many vectors. These are all vectors. I bar alpha. Unless I got I bar wrong. Radius of gyration. 0.04. Yeah, I got that right. I mean, it's in the area now. I wonder what it's. I wonder what's Let's see. Maybe do a little look-see. Let's see if this problem exists on Solution Guide. We've checked over everything. And we can't find it, which is, you know, great for us. I don't need that. What do I need? Oh, we're here. What is it called? Engineers for engineers. Yeah. 113. I swear to God, if it's just some like adding thing, I'm gonna cry, guys. It's so often the time it's just like I didn't write a 2. I needed to write a 2. They go, Damie, you need to write a 2, and I say, I tried. It didn't work. Let's see. Okay. Make equals 0. AO equals R alpha. Okay, we did that. AA equals AG plus A to the respect O. So we have R alpha and X bar alpha. Alpha and... Did I do that? 0.18 times... okay, wait, I didn't do that. Why is that X bar alpha? With respect to O. Wait, no, it's not. It's not 0. Oh, wait, I'm looking at the wrong thing. I just started looking I was like, we did this, oh, we did this, oh, great, it's great, everything's great, it's awesome. Literally not the problem we were doing. It was the hemisphere one, I was like, oh, that's great. Oh god, oh, okay, they did a moment about C. We're winning. They did a moment about C. Okay, acceleration of A. What is A bar? They're saying A bar. I don't know why they're saying A. PR minus WR. ER. ER. Wait, did I? Uh-oh, guys. Oh no. Oh no. Yeah. Oh, that's. Oh, oof. Oh, that one hurt me. There's two forces here. I didn't do the moment about the MG. I got too excited and I just wrote P and I didn't write MG. Oh, I didn't write MG, guys. I didn't write MG. It's gonna be a negative moment. It's gonna be positive when it goes to the other side. Oh, woe is me, and then it's gonna make it bigger, and I think that's the only thing I missed. Oh, wait, that's good though. Okay, well, not... Tier 5 bits, oh my gosh, thank you so much. For the 5 cents. This gets crazy, you don't have to pay me money. You bet. Oh, you're so sweet. For me not doing... I can't believe I didn't do a moment for the weight. Man, that's like the easiest trick in the book. You take the moment. I've been doing that for a year. Oh, Mom. It goes to show you. That happened. Nickel for your thoughts. Thank you. My thoughts are, oh my god, I can't believe I didn't take the moment. I was so confused. I was like, I set everything up so well. And my watertight logic, very not watertight. Okay, that's okay though. My intentions were good and true. They were just wrong. Wait, MG. I don't need to multiply by anything else. That's MG. All right, let's see. Okay, if I do this and we take what we got, don't make it negative, keep it positive. I lost it. 3 point this plus 1.5 times 0.018. Didn't really add that much to it, actually. Why did that add so little? Oh, because it's... Okay, no, I'm lying. I'm awful. Well, that's an exaggeration. I need to add it to the top, and then it'll make it better. I don't know why I... That's so weird. I can't believe I didn't take the moment. There's too many things. There's too many things to look at. I just get too excited. Okay, but that's still 4.3, which is also not the thing that it needs to be. Doesn't it need to be 8? It's 8. It's 8. Okay, we're getting closer. We're finding things. Okay, 4.3 is where I'm not gonna box it until we get it right. That's sad. Okay, 4.3. Okay, knowing that. Well, let me see. Maybe my guiding equation is like also missing other stuff. M-A-Y-R, M-A-X-R, I-bar. Okay, wait, I did that. Cool. Really don't know how I could have gotten it wrong then if, I guess they did it all symbolically, which, you know, would make my life easier if I could just check my symbols against theirs. Although, they're saying P equals mg r over r. Yeah. I don't want to do that. I guess I should just call this R. This is not really R. This is, I'm gonna call it like D. I'll label it on here. That's D. And then this is R. Yeah. So we know. That's so weird though, that means that I just messed up algebra somewhere. Sometimes R... Wait. R... Little r over big R, AB, MA1. Where did they do that? Where did they do that? Let's see, maybe my accelerations are off. So AB plus R omega squared. I did... Well, I guess I could just check. Let's see. So they said in the up direction it's R over R. So little r, which on theirs was... That's D, so D over R. So like 0.018 divided by 0.06 times AB, so times EB was 1.2? 0.36. Okay, so that's right. What about the up one? AB plus R omega squared. Woof. That's annoying. 1.2. I guess negative 1.2. We'll do it all positive. Plus R, which is the little one, times omega squared, which is 5.833, unless I did that wrong as well. No, okay, that's right. Cool. So our AG is right as well, which is fascinating. So where did I just like goof on? I squared K. I multiplied by... I bar equals K squared M times alpha. Let's see, and that one, we know that the value of AX is right as well. So like yeah, wait, what the heck? Let's see. Maybe I can start trying to sort it out. Like, so 2.4417 times, times AB, that's gonna be hard to back out. Or I guess it doesn't actually need to. 1.5 times, Wait, okay, 4.41, wait, where's that coming from? They're getting like a 4, and then plus... Ugh. There's something that's like really small in mine then, because I'm like half off, essentially. I don't know why. Because like all this stuff is chilling. Like literally everything over here, like from here up is good. Let's see, that has to be something in here though, but that's so wacky because like, is it the 06 that's wrong? No, that's right. Oh, I'm not sure actually. That's so weird. Is it like actually half? It's like almost half. It's a little bit more than half. Huh. Fuck it, we ball. Let's do something else. Just gonna jump around. This one is actually not too bad. Oh, this one was the one where I was getting a lot of, Oh, this one, yeah, because I think this is the inches, feet thing. Yeah, because if I'm using pounds... Well, okay, it doesn't... It's not like that bad. I don't think I actually goofed it like right away. I would have goofed it if I kept going. Maybe that, because the other way change from millimeters to meters. Okay, let me just change this to feet real quick. So this is what, 240 divided by 12, 20. So 23,888. That's really what that is. Oh my god, that's huge. Divided by 12. Okay, that is giving me confidence because that is actually divisible by 12. And I like that. Feet per second squared. Feet per second squared. Before they come down and kill me. I'm gonna go to the whiteboard. See it a little bit better there, I think. Okay, let me check one thing. Oh, I have that open twice. Okay. Okay. I got some stuff here too. So this one we just got. Oh boy. Okay, we got A of B. So for this one, we have a sliding little guy, and we're trying to figure out the reaction at D. So we need some stuff at the centroid. So we just got the acceleration at AB, but we need the acceleration at G. So we'll have to do another related one. AG equals AB plus AB with respect to B. That's 20, 3, 24, 0. And then G with respect to B. There's an alpha that we don't know, but that's okay. Zero alpha. Then we want the not a huge fan of having the sines and cosines, but I don't want to tilt the axes because B and D are in these, and I feel like that makes it easier. Oh god, if I really hated my professors, I would switch my axes to be Y and X. I wonder if they would take points off just for doing that. It would probably mess me up though, I don't need to do that. I don't hate them that much. Okay, G with respect to B is gonna be negative, negative. Do I have an angle? Where's my angle? Oh, I don't even need an angle. You can just do it. So it's gonna be down 3 and over 4. I guess it's positive on the 4. Oh, my pen just started goofing. Okay. Is there an omega in this bar? There is an omega in this bar. Which is... that sucks, actually. Because I need to find the omega. Well, maybe I can, maybe what I can do is say... maybe before I can do this, I can try and finagle some things around here. So we know that the reaction at D equals MAX. And we know that AX is going to have some terms of alpha in it, and AY is going to have some terms of alpha in it. So what if we solve this one in terms of, so if we have negative 4b equals 1/12 ml squared alpha plus 3d, because we'll have some alphas in there, we'll have d in there. And then in terms of b, we can say b equals may, which is going to be alphas, plus mg. This is going to give us alphas, this is going to give us alphas, and d. Yeah? Oh my gosh, Cosmo, how's it going? What's up? I need to get an omega. I don't want to get an omega. It's going so well, that's great. That's awesome. How are you? Oh my goodness gracious me. I'm good. I'm good. I'm enjoying myself. Except for trying to find this one value that I just like, I'm stubborn and I don't want to find. Also, I don't know if this is gonna... These stepping stones I don't think are the correct stepping stones. You are so real. Thank you. I just don't have like the pathways yet between these because it's like it's so different than how normal, like, or how less complicated physics is that it's really hard for my brain because it's like, okay, it's like I want to find D, and I know AX is going to be in terms of alpha. So I need to solve for alpha. But like, how do I do that? You know? I'm gonna get rid of this real quick because we have to solve for that omega. Size so sadly. My VG equals. Wait, can I even say anything about VG? No, I need to say VD equals, oh boy. Maybe I have to do that for that one too. Wait, that might make my life easier. Finding values can feel like a sliding puzzle sometimes. That does make sense. Yeah, it's exactly like that, and I just haven't like... It's like frustrating because my professor's like, oh, it's just the same thing. And I'm like, it seems like a lot more sliding around stuff. Like, I can always see it when it makes sense, but like, I'm falling into the river when I'm crossing these metaphorical stones a lot of the time. I can find alpha, I think, by doing this instead. If I did 8 and then -6. Because then I can say plus omega squared. Did they give us an omega of the crank? Wait. They gave us the angular acceleration. Never mind. Wait, crank AB. Never mind, I lied. we have to do this still. Can I get away with... I think I can't get away with that because I think I need to find the omega of this. But I probably should do VD. VB plus B. B with respect to B. Like, I can do this easily. But this is also not the hard stuff, you know? 0, 0, omega dB. I'm gonna say omega G actually, because that's what we need it for. And then that's 8, -6, 0. And that's gonna equal 0 VD, or sorry, VD 0, 0. Looking at my diagram, because it's only gonna... Nope, I lied. I don't know. Oh, that's because that's the force. Lol. It's only going to be able to move up or down, so we can get rid of the other ones. So we have 36, 0, 0, negative, WG, just because cross product, and then times -6, 0, oh, -6, -8. Equals, okay, so we want to say 36 plus 6WG equals 0, so WG equals -6. Right? Great. And then, okay, we have this alpha. No, we don't. That's okay. Yes, it's okay. I'm like, so -6 squared. I should probably try doing one of these. Maybe I can redo that other one and see if I can do it symbolically. Because I probably should start doing them symbolically. I mean, it's easier for professors to grade. But also, I'm vengeful. That's not why. I'm just, it's hard to break out of habits. AB 0. Okay. Look at all these stupid vectors on my screen. I love them. They're funny to me. They're funny little guys. Unfortunately, we need all these, so, Evil, vengeful spirit, damie arc. My math teacher is a vengeful spirit? Question mark, exclamation point, interrobang. I think that would make a good manga. Okay. I'm just gonna say -6 because I'm lazy. There we go. It's also less likely I'll get it wrong. Look, like if you you venture onto the floor, you're like, wow, this is such a great problem, and then bam, cross product jump scare. My math teacher's a vengeful spirit, interrobang, gone wrong, 3 AM, I died. Question mark. Oh, that's great. Okay, so 20 plus 6 alpha minus, what is 6 times 8? 42. 48. 48? 42? 48. I think. That was the one I always got wrong as a kid. So I had to remember that 8 is selfish and wants to put an 8 in there. So it's 48. Little odd things you do to try and get yourself to remember multiplication tables. Okay, I don't know what that is. That's like 10 and a little bit. 68 divided by 6. 11.33. Oh, I meant 11. Okay, I kind of wish it wasn't 11.33, but that's fine. Well, now what do we do? So we have an alpha. Oh, wait. Okay, now we have to get the acceleration at G. Why is this just a big kinematics problem? What do we do, chat? You want to do alpha from... Let's do it from B. Sorry, I didn't give you any chance. Wait, I wrote G here. Don't do that. B. Are you ready for more numbers that I'm writing exact same over again? Oh my gosh. I don't really have to... You know, I don't have to do this. Let's maybe be smart and let's not redo work that I already did. Minus alpha. I'm just gonna change this to half of it. Okay, -6 squared. I didn't square that. I didn't square it anywhere. Well, what am I doing? What am I doing? That's... Oh my god, it's so much bigger. Uh-oh. 6 squared? Oh, that's so big. Oh, it's so wrong. I don't... Oh, wait, I said 68. 68. 228, okay. I was like, that's so wrong. Okay, 222, 228? 288. And so it's, 308? This time 308 is divisible by 6? Nope. 51.33. Numbers in my damie stream? I want my money back. I know, right? Who is this guy trying to teach me numbers? Ew. Resident Sleeper. Uh-oh. Oh no, it's fine. 4, -3, 0. Is that right? 4 over 4, yeah. Wow. Who does this guy think he is? Almost like he's... thinks he's an engineer or something. No way. What was I doing? Oh, yeah. Okay, I need to get these. So this is going to be 20 minus or plus 3 alpha minus 36 times 4. 144. This one's going to be 324 plus 4 alpha plus 36 times 3. 108. So now we can set d equal to this, finally. D equals, literally just negative d equals max. And then we can do it. Equals. What's m? I forgot. Does anybody remember? I don't. 3 divided by 32.2. It's gonna be wrong. Are we ready, chat, for this to be wrong? AX is gonna be 20 plus 3 times 51.33. Okay, minus 144. Okay, ready? Everybody clap and cheer when we get a wrong answer. It's okay, I'm memeing, but my soul is dead. So, it's okay. Okay, 30. That's like 30. Wait, maybe this is kind of right. Okay, maybe. I'm holding out hope. Generally, you don't get even answers if you screw up. What if I frown and booted through tomatoes? Times 3 divided by 32.2. Okay, 2.3 newtons. That is not what it is. 2.8 newtons. To the negative 2.8 newtons. Okay. A big moment. How wrong are we? Okay, so it's the wrong direction, which is great. At least it's in the order of magnitude. It's 5.51. Size deeply. Okay, let's see. Maybe I can figure out where it went wrong. What problem is this? This is 120. 26. Okay, it might not be here, so, you know, grain of salt, but if not, we'll figure it out the old-fashioned way by praying really hard. Okay, it's a little different, but it's a similar thing. So we find the omega and we find the, or, well, okay, we find the, yeah, we find the VB and we find the AB. Oh, wait, did I do that? Yes. 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 No. What? Yes. No. What? Wait, what? Wait. Wait, why do they not have a 15? Ooh, oh no, okay. Okay, they did do that. I was like, what is happening? They don't have this thing in here. Oh, they did an instant center. Get out of here. I don't care about an instant center. Oh god, what is this? This is scary. Where's their instant center? Their instant center is at C? I don't know where C is. They just did a random instant center. Okay, we don't do that here. Okay, well, we had a good run. I don't know about that one. I don't know about that one either. That one is a little wacky. Let's see. Wait, I'm just seeing if it's like around here. If it's not, then it's not, and that's okay. Well, let's see. Let's just bounce around to other stuff. Well, we can go. I kind of want to go back to that. I was thinking about this one. I've been thinking about her. She's beautiful. Who is she? A dynamics from. Let me draw. Let me draw. Let me draw a little. my demons interrupting this beautiful moment. This is so sad. This is awful. Where's her centroid? Her centroid is... I'm not gonna draw that. Her centroid is like here enough. There's centroidal axis. It's acentroidal axis, I guess one could say. Weld my arm to a chair, if you could please. Oh, what if I gave her like little arms that were like forces? Oh, that would be so cute. I like that better than that. I wanted to give her like kind of hair somehow. This can be like I-bar somehow. Don't ask me how this is I-bar. Don't worry about it. It's I-bar. Oh wait, if I make okay, I can maybe spin that as a radius of gyration. You know? my wife's radius of gyration. That's beautiful. I can't weld your arm to a chair. I'm not welding certified. Yeah, I can't do that. I don't know if I'll ever end up getting welding certified. I don't know if there's a reason for me to be welding certified. I say that as like, I could probably back alley weld your arm to a chair. Actually, that would suck. I will certify you. Sure. Welding is really hard, guys. What kind of welding? MIG? I don't know. I don't legitimately know if I could weld. Like, if you asked me to do TIG welding, I don't think I could genuinely weld your arm to a chair. I have all the welding credentials. I promise. I promise you. I tried to weld tungsten inert gas, TIG welding. I tried that. We were welding on solid blocks of copper to make it easier so that our aluminum, we didn't blow holes through it. I still blew like 20 holes. Welding. Wait, did I not do any accelerate? Wait, yes I did. Okay, wait, so let me do this. So that means that AX equals alpha R, AY equals, sorry, AX equals negative alpha R, AY, not alpha Y, what the hell am I doing? There we go. Okay, how many unknowns do I have? Again, so if I count like everything is an unknown, and we're gonna count these other two equations. So 1, 2, 1, 2, 3. Wait, sorry. 1, 2, 3. This one's the same, so that's not 4. This one's already taken care of. 4. 5. And so we have 1, 2, 3, 4, 5 equations. We should be able to solve it, because none of them are redundant equations. They're all interesting equations. But how do we put them together? How do we put them together? I mean, I guess I could solve alpha in terms of AY, but I don't really know if that would help, would it? I just don't see how I could get anything out of any one of these right now. Because I can't put anything in terms of all the alphas. Wait, okay, let me see if I can get a jump start on this, because this matters. So they did moment about, okay, they did moment about A. Did I do a moment about A? I did a moment about G. Ah, interesting. Oh, so they got rid of the friction force. Maybe that's the way to do it. Okay, so let's try and change that, and we'll see if we can kind of pick it back up. Okay, so moment about A instead. Let's really make sure I get all the forces this time. So this is A. Okay. So we have a weight. That's the only thing. Okay, it's a negative. So negative weight times 3/8. Should I just give it a name? I feel like I should just give it a name. OG. Cool, so we have on the other side I bar alpha, which is a positive. And then we'll have a positive plus MAY times R. And that's minus MAX times OG. Nope, this one's R and the other one's OG. I can't just do that. OG. Move it over a little bit so we space. Minus MAX times R. So in that case, we have, oh wait, so yeah, that's the one we needed because we know everything. And we can get weight, and then through weight, wait, do we know the weight? Yeah, we do know the weight. So we can get what alpha equals. Okay. Get out of here. I used the wrong equations. I maybe could have solved it. I mean, technically you can do it with any moment, I think, but it just makes your life like... Okay, so this is weight, negative weight times 3/8 R equals... Oh god. Okay, I'm gonna just call this G. I'm gonna get rid of an M over everything, okay? So we're gonna do 2/5 R squared minus OG squared. This times alpha. Alright. Plus AY. So that's AY is 3/8 alpha R times OG. So 3/8 alpha. Sorry, 3/8 R. Minus, we got rid of the M, so plus alpha R times R. Okay, there's a lot of things. Let me rewrite this. Two-fifths R squared alpha minus OG squared alpha plus, I mean, should I just maybe clump it all together? I mean, we have an alpha, it's already started. Yeah, I think I'm gonna clump it. Okay. Try my best. Alpha times, so 2/5 R squared minus OG squared, that's what we have the alpha. Then we're gonna have plus a 3/8 squared R squared. I feel like the OG, I should keep it all OG. OG is this, and this are OG, so OG squared. Oh, okay, so those go away. Look at that. Plus R squared. Oh, okay, yeah, so, okay, that's what it was. Negative 3/8 G R equals alpha times, if we add these two together, that'll be 7/5 R squared. We can cancel out that and that. Alpha equals negative 3/8 G times 5/7 R. So like negative 15 G over 42? No, 54. Multiplication. Okay, that's great. We have a value for that. What are we trying to find? I already forgot. We need n in terms of stuff, and we need... Okay, we need lots of things. So now we can say n equals m times g plus ay equals m times G plus 3, or OG, I guess, alpha. And then we can say that n equals mu sub s, or no, sorry, max over mu sub s equals m times negative m alpha r over mu sub s. And I think we can maybe cancel out some stuff, possibly, and if not, then our alphas they'll be great, it'll be fine. So we got G plus OG alpha equals alpha r over mu sub s. So we got mu sub s equals, oh god, alpha r over G plus OG alpha. Yeah, equals negative 15G over 44R times R, so these go away. G plus the R's are also going to go away. Wait, this is great. This is a number. It's not a great number, but it's a number. Negative 15G times 54R times 3/8 R? What is this number? Most normal dynamics number. What is this thing? Okay, negative, what have we got? Negative 15 times, are we in 9.8 even? I don't know. I guess it doesn't really matter because they don't give us units. How do we know what? Oh wait, the G's are probably gonna cancel out, or in some way. Oh yeah, because we can factor out a G. Oh chat, we're winning. Okay, G. Over 1 minus 15 times 3 over 54 times 8. Okay. What is this number? 15 divided by 54. Uh, 0.31? No, but it's kind of close, and that is okay. Okay, wait, so getting it kind of close is fine, actually, because what we need to figure out is how do we see the things. Okay, so what did we use? We used this one. We used this one. We used this was the most important one. We did use this one as well, so that one. And we also used this weight, so we used all of them. Okay, well, I guess that would make sense because it's 5 equations, 5 unknowns. So let's see. How do we see this? So I was saying, like, okay, let's take a moment about G. That gets rid of our alphas and it gives us more unknowns. So you have to take a moment to get rid of the force to relate the weight to alpha directly, because you know the weight, so you can find alpha. Ah, okay, I see. It's about this dude and this dude. So okay, I think it's like trying to eliminate stuff so we can find alpha directly, and then going from there, because everything else is connected to alpha. But you need to find alpha, like in one step, not in like a system. I guess we need to find the corresponding acceleration point B as well. If I'm gonna find the acceleration at point B, I'm gonna use, so use given. Given mu sub s. My brain just shut off. Okay, we need to find it. Wait, oh no. Oh no, my alpha. Oh, actually, that's okay. That's okay, because we can have, we don't really need that. Unless my alphas are wrong. Which, you know, I guess they could be. I kind of don't. I'd like to think they aren't, but. So I guess so, AG equals negative alpha R 3/8 alpha R equals, it's going to be 15G over 45 3/8 15G over 45 54 blah. And we're looking for B. Oh god. I don't have enough space to do this. Let's come back to it. It's not bad. This one is also weird. That one's fine. That one we might not be able to do. Oh, this one. Ugh. This one is a funny little guy. I think I got kind of lucky doing this one because I saw the way of doing it. Okay, so first off, I started with doing the acceleration of P. I thought, okay, so we probably have to do the acceleration I bar alpha because they might be two different alphas. Because it's only pinned at one place. And so I thought, okay, I'll do the acceleration at P is the same as, you know, point P, so we can do like F equals MA over on the right side of things in the free body diagram land. And then you can relate that to C, because we're trying to find the reactions at P. Yeah, so I said that, and I said F of X equals MAX equals MAP. Yeah, so that's going to be like our two basic things. The AG I said equals alpha R, because it's a rotating, it's a rolling cylinder without friction. And then we say AP equals alpha R, and we put in an alpha. I should probably be a little more specific about that, because this is alpha, like a circle, I guess. C is an awful name for it. Alpha G. That's alpha G. So I essentially found alpha G. Not but I also found, like, I set up AP, right? So why do I have this just here? Oh, P of, wait, oh, did I take a moment and I goofed again? No, I just summed. Px equals MAP. I guess maybe I could also do, I'm kidding, because I know AG. Maybe the thing is like AG isn't equal to alpha R. Would it be equal to, oh, maybe it's not because it's rolling on an incline? And so we don't know if it's exactly... let me do this. Let me copy it. I think it might be that it's rolling on an incline, and so we can't say that it's equal to just that. Which would suck. I don't know though, because that feels awful. Ugh, it's just so annoying to not be able to see the threads right now, but that's how it be. That's how learning be. Always good to be kind to yourself when you're learning stuff. You can take away anything from any of these dynamics videos. Probably that. Probably even the people who know what they're doing struggle with things, and it's okay. I'm just gonna write down a bunch of equations, and we'll be able to see a through line. So sum of f of x, I guess for c. I did call it c. If we sum fx, it's gonna be mag, and it's going to be px plus mg sine 20 degrees equals, I kind of want to do it, maybe let's try and do it, what if I tried and did it, I tried to do it symbolically. I don't know, just for fun. So then if we have f of y equals 0, with py plus n equals 0, at least according to my... That would mean py equals n. Oh, maybe I only found px and I didn't find p... Oh, well that would also probably be part of the issue. I just found px and I was like, I'm done. No, there's another reaction there. It's also not that, because there's a weight. There's a weight in there, okay? It's not that. Plus n minus mg cos theta equals 0. Okay, and now if we want to take a moment, we want px and py probably in terms of alpha, or what's something where we want only alpha. Get rid of px and py by taking the moment, and that would be kind of great, but you still have n in there, and n is like a floating guy. But we do know more about px and py. But I mean, you can't, I don't know if you can assume that these are the same alpha. That's what I'm wondering, because if this is alpha c and this is alpha p, because then you could get px and py in terms of I bar alpha p. You know, you could. Oh, could you? Actually, maybe you couldn't. Maybe let's try doing some over here too. So sum of forces in x is going to equal m ax. Kind of a weird. Maybe do it p. It's going to be px plus mp g cosine theta mp ap mpat, and then we have fy equals equals 0. So that'll be okay. So we can find py. So py minus mg sine theta equals 0. So py equals, okay, wait, this is good. Py equals mg sine theta. So then we can put this in here and we can say n equals. And then we can use this when we're doing the, moment about, wait, if we do a moment about p, we don't have to worry about, we actually only have to worry about mg. Oh. Wait, what am I trying to find? I'm trying to find py and px. That's still okay though. So mg cos theta minus mg sine theta, or mg cos theta minus sine theta. That's great. That's just a number that we know now. I love that. Because we know py, yeah. Okay. And then, okay, now we want to do moment about p equals I bar alpha c plus r, it's like pointing to the force, so r g with respect to p cross m g a g. Okay, okay. Take this with respect to p. The components in the x or the y are going to go away because they're going through that point. You push on a door handle, it's not gonna rotate. We push a little bit further away, which is this right here. So that's gonna be h, I guess, 8 inches. And that would be mg cosine theta. So mg cosine theta times h. Is that gonna be positive or negative? Well, it's gonna be positive because it turns that way. And I bar alpha. I guess I'll just leave as I bar for now. C plus RGP is going to be our... Oh, it's great. It's just, here, I'll do it as a cross product. Okay, wait, shoot. This moment... Oh, it's a moment. What direction is that moment? I guess in the zero... It's in the z direction. Guess. I'm not too happy about that, but we'll just see. That seems bad, but I'm not gonna think about it too hard. Because this one is also gonna end up in the z. We'll see. We'll see. Well, because this is also gonna be in the z, right? I'll turn this into a vector. 0, 0, alpha c. Okay, no, I feel a little better now. I feel a little better. I was a little worried. Okay, so it's gonna be, we want pointing to the force, so it's gonna be negative y. And then cross mgag. mgag. That's gonna be, I guess, in x. This is crazy. I don't tend to do moments, whatchamacallit, I don't tend to do moments in actual, it's been a long time since I've done them in cross products. But that's okay. Let's see. That's gonna equal I bar, which we can find, but I'll just leave it as that for now, because we're doing symbolically. Minus, oh shoot. I can't take my cross product easily anymore, okay. So this is gonna be a positive, so it'll be minus h times, times 0, 0 minus mg ag. Makes sense. Okay. So then we get mg cos theta times h equals I bar times this minus plus h times mgag. So this c equals mg h cosine theta minus ag, and then over I bar. Maybe? I forgot what I was trying to find. px. Wait, but that's like cyclic, because I need ag. But I can find ag, I think, with alpha c. Let's do that then. It's omega, negative omega squared r z with respect to g. Like that. And then added alpha cross r with respect to z plus or minus. Okay, these are gonna go away. It is just alpha cross r with respect to z. So ag equals, oh god, I'm not gonna like write it out like this, but we're gonna like get this c. And then I guess that would just be, do we have an r? We do. It's just g with respect to z is positive r. It's like negative ac times r. Okay. We're getting somewhere. Where's it going with this? EX, yes. But I still need AG. Oh no. How do I manage AG to end up with my alpha in AG? Oh. That's a cyclic definition. How did that get in there? I don't like that. Get out of there. Get out of there, little guy. Like a little imp. You're messing up my day. What the heck? I can't define it as I can't define alpha as something with alpha in it. That's illegal. Well, I mean, I guess it's not illegal, it's just recursive and unuseful. You never get to open your present, then. You just keep opening boxes forever. And the present is the box, but also it was the gift of opening the box, but you never get a solution. You have to open boxes forever. Well, let's see. Maybe how else could we find AG? AP and AG aren't the same, but we can relate AG to AP. Do we know AP? We do. We know that it's PX. Or yeah, PX, whatever. P, AP, or PX. APX. I mean, I guess we could try that. That seems a little in the weeds, but why not? Why not? What else will we gotta do? We don't have anything to do. AP plus A G with respect to P. How do we define AP? Well, we say that it's PX. That's also not great, because PX is in this one. But that's okay, we're just gonna go with it. Over MP. Now, Also, again, this is, well, this is in the I hat direction. So I mean, at least there's that. It is a vector. It's like kind of a weird vector to have, but you know, it's a vector. And this would be times AC, but like our AC is defined in terms of AG, and I don't like, okay, maybe what if we, okay, the only way to get rid of that would be if we took a moment about about M. Maybe that's the solution. If we take a moment about M, Py is going to go away. Px is going to be our only thing. We'll have I bar alpha. But we won't have to deal with... We'll have a different definition for alpha C, question mark? I don't think this is it, so let's try a different moment. Goodbye moment. Actually, I'm not going to get rid of it, because maybe it's... I'm just going to get rid of that one, though. Put that one on a different layer, just in case. Okay, moment about G equals I bar alpha. Clean, simple. I'm loving it. I think this might be the way to go. Is this what I did last time? No, I just did weird stuff last time. I don't know what I was doing last time. Okay, let's try this one. Okay, P is going to make a negative moment, so negative Px times H equals, there's no other things? There's no other things. Equals I bar alpha. Alpha equals Px times H over I bar. Then if we say, sorry, let me put on some other tunes. Oh, it just paused it. I'll say, I don't think I got through the entire soundtrack this morning. Okay. Then if we say, right, this is for C. We say Px, or sorry, we say Ag. Well, we know that Ag equals alpha C times R, right? So Px plus mg sine theta equals m times negative Px times H times R. Only one unknown in this. So what would this be? Px, I guess everything times I bar. Ipx plus, let me move that over here, plus m r px h. That's the sound I make when I get up in the morning. Okay, we got this. I'm just gonna move this guy over here. And then I'm gonna factor out all the gunk. Okay, okay. This is looking I don't want to say promising, actually. I feel like this is also sort of weird. But that's an answer. Should we plug things in and see what it is? Yeah, maybe, maybe. Okay. Okay, what have we got? mg 4 sine theta, sine 20 over I bar I don't know I-bar off the top of my head for, I think it's 1/2 mr squared. I-bar for a cylinder. Whoops, that's not it. That's a joule. It's mass moment of inertia. 1/2 mr squared, yeah. 1/2 m, so 4 divided by 32.2 r. 16 inches, but we need feet, so 16 divided by 12 squared minus 4 over 32.2 times 16 over 12 times height, 8 over 12. Oh, you know, we're just normal numbers. We're just normal numbers, normal men. Okay, 4 sine 20. 0.5 times 4 divided by 32.2 times 16 divided by 12 squared. Then 4 times 16 times 8 divided by 32.2 divided by 12 squared. Okay, so that's 0. Wait a second. What? What did I do wrong? Why is it 0? Why is it 0? That's so... it's exactly 0. What? What the heck? What? Oh my god, okay, wait, we have to look into this. Why is it exact? That's so funny. It's exactly 0. That's the biggest, like, you do not know that you could ever get. It just being exactly 0. That's so... what the heck? They hate me. They got me, guys. Is it this one? Okay, it is. Ugh. What the heck? Okay. I guess they're just doing some mass moments of inertia first. Let C be the point of contact between the cylinder and the incline, and point G be the mass center of the cylinder without the bar. Cool. Alpha A. Okay, so for rolling out without slipping, alpha G equals RA. We got that. AP equals alpha G plus HA. Did I use that? I didn't. Not really. What did I use? I used the top one, and I used AG, and then I used the moment. But to get PX... oh, no, I just got PX. That's not really an issue. Huh. APH equals H omega squared. Yeah, sure, I did that. Moment out C. Wait. They did a moment out C? I tried doing a moment out C and it didn't like me. Wait, why can't I do a moment out P? Wait, not a moment out P. I mean moment out... why can't I do a moment out G? Wait, this is so sad. I tried that. Man. Oh wait, also they have... wait. Oh, they did... okay, okay. I think I see. Because you can't, like, separate the diagrams like I did. You have to put them together on the diagram. That's a pretty important thing. Because it's MAG plus all of this stuff. God damn it. God damn it. Okay, we're gonna have to do it again. I'm gonna have to redraw my nice diagrams too. Actually, I'm not gonna have to redraw that much. I can actually leave them. This is the only thing that's different. But do they have two different omegas? They do not. Or sorry, alphas. They have the same alpha. So they're assuming that it's the same alpha. That's fascinating. I mean, I guess if it's pinned tight enough, then it would be the same alpha. I just can't constrain a moment, so I figured, you know, it doesn't constrain a moment. Again, me not assuming enough is well, this is fascinating. So we'll have to do that again. Let me see. Let me check if these diagrams are right. Okay, they just guess some different directions of things. That's fine. Get rid of this a little bit and move this over here, just so we can see a little smarter way. And then let's see. Got some. Oh, there's another weight. Yes. They're assuming some directions for that to that. Oh, they're not assuming, so they're not assuming the P goes in only this direction either. This is going to be APX, I guess, and APY, which, yeah, that makes sense, actually, because it's a point on the... This is also I bar alpha. Or I bar bar alpha. This is I bar cylinder alpha. And then over here we need the weight as well here. MBG, and this one is MCG. Okay, well, Jayo, let's talk about. Now there's a lot more things, for sure. Oh god, okay, well, see, the moment about P is now much more apparent because you don't want all this garbage on it. You can't just say, I want... Wait, but they don't do that. They do a moment about C, right? I guess it doesn't really... I mean, again, it doesn't really matter where you take the point, as long as you do this stuff. So what do they start with? They start with accelerations of things, and then they just go right for C. But how do you see that it's C? Oh, there's also a friction force here. Which I guess doesn't really... Oh, that's probably why. Because they have zero idea about the friction force. Which makes sense. Okay, let me try and set this up then correctly. Okay, well, what about C? I bar C alpha plus I bar E alpha minus R MAG. I guess it should be like this. I just want to do them as moments and not have to R plus H. Not have to worry about the vector side of stuff. Alright. I suppose those are also magnitudes. Okay. So in the mono C part. Okay, first off we have MCG. It's a negative. Times R. Minus PX times R plus H. And then we also have a minus MBG. Oh, whoops, also, it's not that. There's a sign in here. The sign? It is sign. Thetas are the same, because that's how it be, which is great. MBG times R sine theta. Sorry, R plus H. I probably put it sine theta R plus H. Equals all this stuff. minus R M A G minus R H M A G. Oh god, okay, that's a long boy. That's a long boy, as we say in the business. Well, what do we know? We know MC, we know G, we know R, we don't know PX, we know MB, we know H, we know IC, we know IB, we don't know alpha. I'm not given alpha. We don't know AG, but we can find AG. We need something else, I think. Because if we have PX in here, how are we supposed to do anything with our lives? It does make sense though that the reason we have to get rid of this is friction, and so I didn't put friction on here, and that is bad. Love that. Okay, AG equals alpha R. I mean, I can write it in a little. We know that. Just based off of the way that we say it's rolling. Okay, also, I'll change that one, because I mean, that one, we know it's rolling down. It kind of is hard to say. Oops. Kind of hard to say otherwise for that one. IB is probably also going to be down, but whatever. As long as it's consistent. So we know AG is AR, so, or alpha R. This one is good. We don't have to worry about that, but we still have 2 unknowns. Let me see. Let's see, MD, GR, theta, E. They pull an alpha out of like all of it. Okay, so they just leave the... Wait, also, if they take about C, E is just gone? Question? Oh no, AP. Where's PX though? Where's PX at? Huh? Wait, it just seems like they don't have PX. Using the cylinder plus the ball, thus. Oh, they did overall equilibrium. You know what? Okay, before we end, because I'm probably gonna wrap soon, I'm gonna do this. I'm going to get extra examples, and we're gonna go and we're gonna do some. I want to do one where I can like set it up properly, use all the stuff that we learned, and general motion on the FMA. Okay, so overall equilibrium is something we need to maybe use. Okay, this robot one might be good. A fire truck with audio? What does that mean? This one is called fire truck with audio. Does it play fire truck noises when you go to it? I hope so. Sorry, you don't have access. I'd like access. That's funny. Okay, well. Okay, these are videos. I don't have any I don't have any forces or anything, Professor. What's going on here? Okay, maybe we just do one of the ones that we did in class. I probably won't remember them that well. Angular acceleration. This one, I guess, is also pretty good. Sure. We'll do this one. I don't think this one is supposed to be particularly hard, but that's sort of the point. I mean, I guess we could do a book one, but I don't want to have to like open the book and then... Okay. Okay, release from rest, so omega equals 0. Start with that. Start with a good old that. Let's do some free body diagram. Happy little free body diagram. Okay, weight first. Are we given a weight? We are given m, so we'll do mg. And we know that there's a normal force that goes this way. Hopefully it goes this way, otherwise physics is broken. Any other forces? Nope, that's it. That's only those two. Okay. Now we're gonna say it rotates upward. Just cause, you know, we're so fun with that. I don't know. Could be. We'll say it goes in the positive x and the positive y. Because those are good directions to go. Why not? Put axes on here. Because I wrote x's and y's, and that's fine. Okay. That seems good. There's nothing else in here. So that seems normal. Maybe. Okay. We're trying to find the acceleration of end A. So we need to find AA. The way we find AA is A something plus A with respect to something. I'm going to hazard a guess and say that we do G, because we don't know that much about B. I'm going to do G. We'll say that. So that means that we need... well, let's write out AG. So what does AG equal? AG equals... AG is moving in a circle about A. Like this. But we don't really know... We don't really know about AG, so I guess we can't write anything out exactly. But we can write out acceleration, angular acceleration, which is what we want. Also, angular acceleration of R, right? AA. Cross A, it's for G, and then minus omega squared. Well, omega squared is 0, so that makes our life easier. So that's what we need for AA. So we're gonna need to, you know, we're probably gonna need to get AA through, we might need to get it through FMA, because we don't have this. So maybe we'll probably find this and then we'll get that. And then we want the reaction at A. So the reaction at A, N is gonna, we'll set up an equation for it. So let's say like, let's do some of the forces in Y equals MAY, N equals MG, nope, N minus MG equals MAY, N equals M times G plus AY. We need AY. That's another thing we need. Okay. We need AY. We need like alpha A. I guess AG kind of too. Well then let's take a crack at something. Okay, we can do FX equals MAX. So MAX equals 0. Give me 0. That's nice. We need to find alpha. And we don't know N. We don't know MAY. But we do know about M and MAY together. So maybe we take a moment about okay, if we did, so we have two options. We can take a moment about A, or we can take a moment about G. Let me just do both. We'll see what happens. Let's take a moment. My gut feeling was take a moment about C, bottom. Or sorry, a moment about A. So that would give us I bar alpha plus, let's see, what is that? L over 2 times, I'll just call it theta, L over 2 sine theta. No, cosine theta. Whoops, cos theta times MAY. And that'll give us mg. That's a negative moment. Negative mg times L over 2 cos theta equals I bar alpha plus L over 2 cos theta times MAY. And that's not like unhelpful, but it still means we can't solve it because we don't know AY. What if we try moment about? What if we try moment about G? That would be just equal to I bar alpha. That would give us n negative n times L over 2 cos theta. And there's no other moments there. Equals I bar alpha. Well, we don't know n either. So that's not helpful. But we know that n is equal to... we know that n is equal to... I mean, I guess I could put it into that and then try and solve for 8y. Okay, could do that. But what if I wanted to solve for alpha instead? Let's see, what would I do? I could solve for... Okay, so keep alpha. Solve for n here. Okay, let's solve for n here. Put it in here. And that would give us alpha and AY. And then you solve for AY and you put alpha in here. Could do that. Let's see, let me see how we did it in class. We did this one in class. I just don't, I can get here, I just can't see which place to take the moment about. That's like my main issue. I don't know where to blow up the other components. I need to blow them up more. Where's my blowing up happening? That was not it. Here, we took a moment about A. Okay, we did a moment about A. Why did we do a moment about A? Oh, because I haven't done my relation yet? But, wait, but I mean, why? So first we said that... Oh, we did AY and AX in terms of alpha. Oh, God. Okay, this is what I think. Wait a second. This is what I think my magic wizard mage steps are. Okay. Step 1. Get A's in alpha. So we have to get the A's in alpha first. Then we make a moment with only alphas. So that's like, okay, so if we get the A's in alpha, then by making a moment in only alphas and knowns, we're getting rid of this point, right? And we want this point, so it's not going to be about the centroid. It's never going to be about the centroid. Only alphas and unknowns. Knowns, find alpha. And then, like, use alpha in some forces. How do we think? What do we think? Let's apply that logic here. What am I doing here? Oh god. This one is not a very good logic one to apply. Okay, wait, this is a good one. Okay, so the first step would be getting these. And then we want something with only alphas and knowns. So we don't take it about that. But what do we know? Well, I mean, we know NG and NB. So I guess we could kind of take it on either one. I think I would probably take it about NG down here, just because this is an easier distance to make, and this is like a less complicated. What just happened there? I don't. It like actually exploded all my stuff that I wrote down. It's fine. Probably take it about here. Where did I take it? I didn't write a moment. Awesome. No, I took it about G. See, look, I did that. No, wait, I took it about G. Bro, I should not be taking it about G. Who let me take moments? Okay, like here. We get these in terms of this, by doing related stuff. So like we relate it to here, or we relate it to here, I guess. Or like alpha G in terms of alpha. And then where do we take a moment about? We take a moment about, I don't know if it matters. I don't think it matters. I don't think it matters. I think I would take the moment about D, because we know slightly more about B, maybe. Okay, what about any one of these other ones? Not that one. Okay, this one. So we get these in terms of alpha. That's what I did. I actually did that in this, right? Or well, I actually solved for them. Then we want a point where we can get rid of stuff. So that would be about C. Yeah, take a moment, C. Okay, I think this is semi-solid actually. To get this in alpha and then use, oh it deleted that. Use alphas in some forces. Here, I'm gonna draw a little evil me. I'm gonna put this in my dynamics review, because if I had been told this, or like if I had been like, oh, this is kind of what you want to do to get rid of your 4 million values you have, I would have been so much happier. Because like we did problems, and like I get how to do these problems. I didn't realize how evil I would need to be. With me being evil. Me with my wizard's tomb. My warlock's tomb. There's my book of warlockness. Okay. This guy has a bookmark. Kinda looks like a snake tongue. I think drawing evil drawings of yourself is very important. If you aren't drawing evil drawings of yourself, are you really even a STEM major? I don't know. Studies have yet to show. Do people who draw evil pictures of themselves as STEM majors do better or worse? Oh my gosh. The Mad Mage. Sorry, I got excited. Dungeon Meshi. That's how I feel. When I finally conquer this, I will. The evil lightning bolts. Okay. I think that's good. I think that's real though. Because I mean, like when you're doing forces, you kind of want to like, how do I describe it? Like, if you're doing regular F equals MA, you want to find like a place where you can like sink your teeth into, you know? But in this one, like you have to sink your teeth into the alpha, and you have to get there, you have to do more specific stuff. Okay, well, I think I'm gonna end it there. That's what I got. That's what we got. We did some stuff. There is some progress to be made. It is a little bit of a winding journey, through the woods, the scruff, if you will. But it was fun. Thanks everybody for hanging out, and as always, thank you for sticking with me on my like bumbling misadventures of dynamics. I'm a little bit like Mr. Winnie the Pooh, where I walk around and go, oh dear, that's a moment. That answer is 200 times higher than the one that I should have gotten. Oh dear. But you know, we go on, and that's what you do. You keep going, and you think it's funny, and you draw a little picture of yourself as Winnie the Pooh. Wait, he doesn't have. I need to draw him. Pants out. There we go. Okay, I'll be back this weekend for sure. Yeah. We're approaching speedrun lecture of dynamics, so I'm excited about doing that one because it'll actually be good and not dumb. And most of my dynamics is pretty dumb. I try. It's like you come here conceptually. Pantheon, you know, like we're all sitting around like theoretically doing stuff, but then like as they get up to leave, they just like fall down the stairs. You know, that's how I see it. And it's kind of funny, but like you can't laugh because like you're also about to fall down the stairs. Maybe you don't. Maybe you just walk down the stairs like a normal person. I'm the first to fall down the stairs. Anyway, we'll be back. I'll probably stream earlier too. But yeah, I'll be around. Alright, I'll see you guys later. Bye.